This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to talk about how you can tell if a number is a prime number or a composite number. So let's say I've got the number 137, and I've got to determine whether it's prime or composite. So I could make a list of numbers, 1, 2, 3, 4, 5, 6, let's see. I'll go up to 11, maybe I have to go further than that. And I could try dividing each of these numbers into 137 to see if it's a factor. Now, that's going to be a lot of work, so let's see if I can trim the list down. First of all, I'm not going to bother with 1, because 1 can divide into any number. I've still got a long list, and I'm going to have a rule that's going to tell me not to bother with any of the composite numbers. Don't bother with 4 or 6 or 8 or 9 or 10. And here's why. Let's look at 2. 2 is a prime number. So if I try dividing 2 into 137, I find out it won't work because 2 is even and 137 is odd. And now let's say I think that maybe 4 is a factor. Well, if 4 was a factor, it would mean there would be two numbers, 4 and some other number, that I could multiply together to make 137. So I could say that 4 times, let's say, n equals 137. Now, if 4 times n equals 137, since 4 is 2 times 2, I could also write 2 times n equals 137. But if I could write that, then it would mean that 2 is a factor of 137. But I've already found out it isn't. So therefore, 4 is not going to work either. In this way, you can rule out all of the composite numbers in your list. So let's write this list again with nothing but prime numbers. So now I'm just going to have to check 2, 3, 5, 7, 11, maybe 13, maybe 17, let's see. Well, I've already checked 2. 2 did not work. If I want to see if I can divide 3 into 137, I've got this trick that says add up all the digits in 137. So I'll add a 1 plus a 3 plus a 7. That's going to be an 11. And now I'll take those digits and add them together, the 1 plus the 1, and that'll give me 2. And for a number to be divisible by 3, when I add up its digits, I have to get either a 3 or a 6 or a 9. That didn't happen, so 3 is not divisible, is not a factor of 137. How about 5? Well, the only numbers I can divide evenly by 5 are going to be numbers that end in 5 and 0, and this number ends in a 7. So 5 is out. How about 7? Well, let's see. If I were to divide 7 into 137, 7 would go into the 13 one time, and I'd have a 6 remainder. So I'd have to divide 7 into 67, and that won't go evenly. So 7 is out. How about 11? Well, if I divided 11 into 137, 11 would go into 13 one time. I'd have a 2 remainder, and I'd have to be able to divide 11 into 27. I can't do that either. So 11 is out. And now the question is, do I have to keep going? And the answer is going to be no, I don't. And here's why. Let's say that 13 was a factor of 137. So that would mean 13 times some other number would equal 137. So I could write 13 times n equals 137. Now, n could not be any number smaller than 13 because I've tried all of them. So maybe n equals 13. Well, if n equals 13, that means 13 times 13 equals 137, but it doesn't. 13 times 13, or 13 squared, equals 169, and that's too big. Which also means any number bigger than 13, like 13 times 17, would not work either. So the general rule I've got here says that Once I get to a prime number that has a square that's bigger than the number I'm checking, bigger than the 137, then I've already gone too far. And I shouldn't bother using that number or any number bigger than it. So if we're checking to see if we've got a prime number, we can rule out a whole bunch of numbers from our list. The first thing is we're not going to check with any number that's a composite number. We're only going to use prime numbers. And the second part of the rule is going to say that once we get a number that has a square bigger than the number we're checking, bigger than the number that we want to see whether it's prime or not, then we've already gone too far and we can stop. Okay, so using those two ways of limiting your list, using only prime numbers and stopping when you get to a number whose square is bigger than the number you're checking, should make the process go a lot faster. Okay, that's it for this one. Take care and I'll see you next time.